We're going to resume explaining the work and energy chapter. In this paragraph, we will speak about the gravitational potential energy. We'll start this paragraph by the following question. What is the significance of the gravitational potential energy? The gravitational potential energy is a result of the interaction between a body and Earth. It is an energy generated by the terrestrial attraction. The body S rests on the ground, and Earth attracts it by the force of gravity, which is the weight of S. When the person lifts the body S to a certain height, he has to give some energy to the system body Earth by exerting a vertically ascending force. The minimum energy that has to be given to the system body Earth to achieve the lifting is called the gravitational potential energy. Now, when releasing the body, it falls back to the ground under the action of its weight. The system body Earth loses gravitational potential energy during this fall. During the rise of the body, the system body Earth gains gravitational potential energy. That is to say, the gravitational potential energy of the system increases. During the fall of the body, the system body Earth loses gravitational potential energy. That is to say, the gravitational potential energy of the system decreases. Now we're going to determine the expression of the variation in the gravitational potential energy of the system S, Earth, and the person wants to raise the solid S from point A to a point B, that is at a height HAB from A. To raise this solid S, the person exerts a force F that is vertically upward. The minimum value of the force is equal to the weight of the solid, which is mg. As a result, the work of this force F when its point of application moves from A to B is a work of a constant force. So the answer is F times AB times cosine of the angle between F and AB. F is equal to mg and AB is the height HAB. AB is upward, F is upward as well. This is AB, and F has the same direction as AB. So the angle between F and AB is 0 degrees. As a result, mg times HAB. This is the minimum work of F if the person wants to raise the solid S from point A to point B. This work is equal to the minimum energy dispensed by the person for performing a change in the position of S from A to B. E equals to mg HAB. This energy is gained by the system S Earth and is transformed into gravitational potential energy. The gravitational potential energy at A is denoted as GPE at A, and that at B is denoted as GPE at B. We say then, when raising the solid from A to B, the system S Earth gains gravitational potential energy. This gained energy is equal to mghAB. Or in other words, it is equal to the variation in the gravitational potential energy between A and B. That is to say, it is GPE of B minus GPE of A, or delta GPE from A to B. This is equal to mghab. During its rise, the solid gains gravitational potential energy. The variation of this energy during this rise is mghab. When S reaches B, the person leaves it, and it will fall to its previous position A. As a result, the system S-Earth loses the energy it had gained during its rise. In this case, we say that the gravitational potential energy decreases. Then delta GPE from B to A, keeping in mind the system will lose its previously gained energy, the result should be minus mghab. The negative sign in the variation signifies a loss in energy. Loss in energy. The positive sign in the variation signifies a gain in energy. Gain in energy. In conclusion, the gravitational potential energy of the system S-Earth increases during the rise of S and decreases during the fall of S. That is to say, when S moves away from Earth, the gravitational potential energy increases, and when S approaches Earth, the gravitational potential energy of the system S-Earth decreases. Now to solve an application. We have a cart with a child in it. The total mass is 180 kilograms. The cart moves on the track ABC. The point A is at 18 meters from the ground, B is at 6 meters, and C is at 30 meters from the ground. Calculate the variation in the gravitational potential energy of the system cart, child, Earth when the cart passes from A to B, from B to C, and from A to C. Note that the variation in the gravitational potential energy between A and B is delta GPE from A to B. This is always equal to either positive or negative mghab. So do we choose the positive sign or the negative one? From A to B, the car descends, and as a result, the gravitational potential energy of the system will decrease. Then the variation in the gravitational potential energy of the system between A and B is negative mghab. What is the height between A and B? Let's draw two horizontal levels, one at A and the other at B. The height HAB is the height difference between these two levels. This height is equal to 18 minus 6 meters. And the final answer is minus 21,600 joules. The variation in the gravitational potential energy of the body when it descends is always negative. In part 2, now the variation in the gravitational potential energy of the system as it moves from B to C now. This is equal to plus or minus mgh bc. During the rise of the cart, the gravitational potential energy of the system increases. This variation between the points is positive. 180 times 10 times the height between B and C, which is the height difference between the horizontal levels of B and C. This height is equal to 30 minus 6. 30 minus 6. The answer is 43,200 joules. The variation in the gravitational potential energy is positive since the body rises. For part 3, the variation in the gravitational potential energy when the cart moves from A to C. From A to C, the cart rises. That is to say, we write plus mgh AC. This is equal to 180 times 10 times the height between A and C. The height between A and C is the height difference between the horizontal levels of A and C, which is 30 minus 18. The result is 21,600 joules. Another application on the gravitational potential energy. Consider a thin and rectilinear rod of negligible thickness, of mass 10 kilograms and length 6 meters. It is placed vertically at a point O on the ground. Later on, the rod falls until it reaches the ground and becomes horizontal. Calculate the variation in the gravitational potential energy of the system, rod Earth, when the rod passes from position 1 to position 2. From position 1 to position 2. The variation in the gravitational potential energy when the rod moves from position 1 to position 2. Note that the rod is basically descending, so we use the negative sign, minus mgh. Where is the height here? It doesn't make sense to think of the height as being the height difference between positions 1 and 2. Note that the gravitational potential energy is the energy related to the weight. The weight of a homogeneous rod acts from the center of gravity, which is the midpoint G1 of the rod. As the rod rotates around O, its center of gravity moves like this until it reaches the ground in a new position, G2. Then upon moving from position 1 to position 2, the center of gravity of the rod passes from position 1 to position 2. The variation of the gravitational potential energy when the center of gravity of the rod passes from position 1 to position 2 is equal to minus mgh g1 g2, which is the height between the two positions of the center of gravity. The height between g1 and g2 is here. This height is equal to OG1. OG1 is half of the rod's length, which is L over 2. 6 over 2, this is 3 meters. As a result, minus 10 times 10 times 3 minus 300 joules.